Howdy. So my project is based on understanding Bioglue, which is genetically engineered from polypeptides. So before talking about the Bioglue, let's first focus on what exactly the biological problem that's being addressed by this biomaterial. So the main issue that will be addressed is the need for proper wound closure and sealing of a wound, as well as promoting the healing of said wound. However, to address this problem, there are many challenges that need to be solved by treatment or by a biomaterial. So the first challenge is that the material must completely close the wound. It must either reduce or prevent infection of the wound, reduce the amount of time to complete the procedure, such that this material can be used in emergency situations. Below are examples of treatments that take a long amount of time or can be time consuming for both the patient and on the healthcare side. The material must be biocompatible as the materials will be applied onto skin and even organs. Ideally, the material should also be biodegradable to increase safety and reduce the amount of care needed for the material. The material must have strong adhesion and high fractional strength to ensure that the wound stays closed even under different conditions, such as the wound getting wet. The material must be adaptive and flexible to respond to remodeling tissue, where mobile cells might dynamically change their position and structural order depending on movement or different conditions. Now, the material must also promote healing to ensure that the wound can recover once the wound is sealed. So why does Bioglue solve these challenges, and why would this biomaterial be used to close and heal wounds? Bioglue is a polymer, and many of its properties work well with solving these challenges. The main property of this material is that it has a maximum strength of 16.5 plus or minus 2.2 megapascals. This is comparable to commercial fast-acting adhesives, such as cyanoacrylate. The structure of this polymer is that it is a complex of cationic supercharged polypeptides, which are positive charges along a polypeptide background, and along with it is an anionic aromatic surfactant. The polypeptides were modeled after natural elastin, which can be found in connective tissue where they add elasticity and resilience. The surfactants reduce surface tension. These components were driven by multiple supramolecular interactions, which are non-covalent interactions. So no covalent bonds are formed during the adhesion process, which results in a high fracture strength. So the material utilizes biomacromolecules, which act as adhesive threads, which ensure that the material is biodegradable. Another important property of the material is that it upregulates proteases, which break down exogenous and native proteins, which promote the healing at the wound site and promote the 4 phases of healing. Through the trials, the material was observed to seal wounds in 10 seconds, depicting how much time can be saved, as well as how quick process or procedure can be done. Furthermore, on the skin of a rat within the trials, the first phase of wound healing was realized within 5 seconds of application. Cytotoxicity was also tested, which ensured that the material is biocompatible. Lastly, the material has strong adhesion in both dry and wet conditions, as well as it is dynamic to the matrix and the tissues. So what's the difference between my Bioglue and other treatments? So there are several types of adhesives and sealants, and some of the examples are elastin-based and blood-derived. So these require time for pre-treatment, and once they're applied, they can be irritants to the skin or they can cause secondary damage, so they are not ideal. Next, sutures are also a type of treatment. However, they are time-consuming and have a risk of infection, as well as can cause pain for the patient, as the patient would also have to take care of their wound, and they would also have to come back to remove the sutures. Sutures also have a risk of dehiscence, which is the splitting of the opening of the wound. So recently, there are also some other treatments that include supramolecular interfacial bond formation, which is the no covalent bond interactions. However, they were not strong enough in the different conditions, unlike Bioglue. So Bioglue is able to reduce time and is able to be compatible to different conditions. However, there could be some limitations. Perhaps the fracture strength that Bioglue has could not be high enough for all parts of the body. Further testing would have to be done. It could also incompletely approximate the wound edges and can cause scar irregularities. On the top right is the comparisons of the different types of treatments. These are my references. Thank you.